Hi everyone, welcome to today's STEM Clubs Week live webinar with Anthony Dixon and his talk on natural language processing. Anthony, over to you.
Okay, thanks very much, Joe. I'm going to talk to you today about natural language processing. I work on natural language processing as a lead data scientist with a company called Wyser. So what I'm going to talk to you through today is natural language processing, what it is and why it's important. We're going to be talking through a few applications of natural language processing that I use myself and have used in the past. A lot of my PhD was to do with natural language processing in a crime context, so I bring that in. We'll then move on to how we represent meaning in natural language processing, and that's one of the big advances in recent times, is being able to accurately show meaning of the words that are used in natural language processing. We'll then go on to looking at some further applications by building a GCSE chemistry revision bot, showing you that, and then we'll finish off with some biases. Okay, so the first thing, natural language processing is all about allowing computers to understand human language. This is really important because a lot of our knowledge as humans is in natural language, human language. And what do we mean by that? Well, it means anything that I'm saying now, anything that's written down. If you think about how knowledge is imparted to you, if you're at school, a lot of it's spoken to you. You read a lot of knowledge from textbooks, which is again human language, and you also write down a lot of your own notes. So a lot of the information that humans have is in natural language, and it's good for computers to help us understand that because they're a lot more efficient. So on the right hand side is a little Venn diagram which kind of situates natural language. So natural language processing is completely within AI, artificial intelligence. So it's a subpart of artificial intelligence. And there are parts of natural language processing that are machine learning and deep learning. And there are parts of natural language processing which are more rules-based. So over the past history, and let's say the past 10 years or so, there was a lot more rules-based natural language processing. But now, because of the advances in machine learning and deep learning, the natural language processing is become a lot more powerful. And so the parts that I will be talking to you today and the parts that I'm involved in are much more to do with deep learning and machine learning parts of natural language processing. The other types of language that you might get is things like computer language. So many of you will know that you can code, and when you go in and code things like Python or R, you will get the computer to do things and it can understand that language. That's called structured language and is different to what we're going to be talking about today, which is natural language. It's essentially what humans use and how we communicate with each other. So the next thing to talk about is different applications of natural language processing. So you will, whether you know it or not, you will have used natural language processing, and there'll be natural language processing in things that you do throughout your daily activities. So I'll just highlight a few on these. So you've got across on the, like at the 11 o'clock area, you've got email filtering, so spam filtering. You have natural language models that will essentially read the email that you've been sent, and then they'll either classify that as spam or not spam. And if they classify it as spam, that will then go into your spam folder. So that's an example of classifications with natural language processing. The next one then, talking about language translations at 12 o'clock. Many of you will have used Google Translate, where you write it into one box, some English, perhaps. Most people probably on this call are English. And then in the next box, you'll get it out in the language of your choice. Maybe you're on holiday in France or Spain, and that will then produce the language that you've got there. And that's a form of natural language processing, and that's called sequence to sequence, because you've got a sequence of language and you want another sequence to come out. If you look again at the bottom left there, social media monitoring, you'll see a lot of that about hate and inappropriate content. A lot of that is done through natural language processing. And again, a lot of that is done through classifications. or indeed nearest neighbors where they look for similar things. And then finally, I'll just talk about on the right-hand side there, just above 3 o'clock, is document analysis. You will want to pick out specific parts of that document. For instance, let's say you've got somebody's written to you, maybe you'd want, in a business context, you want to know their name, their address, because you need to store that information later. Some of the work I do with Citizens Advice is we extract data from telephone calls, because they have a legal obligation to record parts of that call in case they need to refer back to it in the future. So that's a couple of applications there. What I'm going to go on to now is some more specific applications, and it will that I've done in my work. And as I explained earlier, a lot of that was to do, my PhD was to do with crime and police data. So one of the things I did was I classified burglaries to see if force was used in order to get into the building or force was not used to get into the building. And what you can see there on the screen is a real description of a crime. The police, when they're trying to put in crime prevention methods, want to understand how the crime occurred so that they can then put in measures to stop it. So a key thing is, was force used to get into the building? And so once you do that, you can then produce further crime. You can then produce crime prevention methods. So two classifications here. We want to classify that crime. Was force used to enter the building? In this case, yes, it was. Or was force not used to enter the building? So once that's done, that classification is done, you can then, the benefit of getting the computer to do that, because obviously as a human, you can read that and that's easy to do. The benefit of getting the computer to do that is it can do thousands in a minute. So maybe when you're reading that, it took you, I don't know, maybe 10, 20, 30 seconds to do that and then to decide. Well, a computer can do that in less than a second. So some of the work I did was I was classifying crimes. What would have taken a human to read, would have taken a human a whole year to read solidly. I was able to do that in less than a week. So you can understand that we've got all of this, or maybe you don't know, but lots of organizations have got all this text, and it's about making sure they can exploit that text in the things they do. The next plot here on the right-hand side, the orange line was the percentages of burglaries that used force. And then the green line where it says flagged, that's actually the police officers that did it. And two things here to notice is that when you rely on humans, generally speaking, they're not as efficient as computers. They can forget to do it. They've got other things. They're busy people. So the computer is more likely to get a true reflection of where and when force was used or where it wasn't. And then in 2018, you can see the green line only starts halfway through. That's because they had a system change in their data. Well, whereas we can go back with the computers and look at old data. If it wasn't done at the time, it's very difficult to do. So that's the crime classifications. What you might like to think about is completely different to natural language processing, is why we get this up and down, this peaks and troughs with using force in burglaries. And it peaks during the winter and it's lowest during the summer. And we can discuss that later, but you might have some ideas as to why that is. Okay, the next thing then, when you've got a classification, when you've got text, is you might want to extract actual bits of that text, because you want some words out of that. I spoke earlier about how you might want some names, but when I was dealing with the police were very interested in what weapons were actually used during assault. So you can see here, again, a couple of descriptions of the crimes, and you're able to draw out those different weapons that are used. And these models, these named entity recognition models, it's called, are incredibly powerful because they can draw out weapons that they've never seen before, because they use the context surrounding those words as well as the words itself to understand if it was a weapon or not. So as you can see here, like this second one, the suspect has hit the victim to the head with and it will learn that if it gets that kind of thing, then the next thing to come up is going to be a weapon. The problem I had with this, though, is that lots of things can be a weapon. And that's, in law, there's no sort of defined thing as what is a weapon or not. And so you end up with huge lists of what weapons are. And of course, some things are closer to each other than not. So a nail is very close to nails, although they're entirely different, separate words. A cane walking stick would be very close to walking stick, but again, separate words. And what we want to do, and what one of the big advances in natural language processing has been, is the ability to understand meaning between different words. So we're really interested in somehow understanding if nail is close to nails, or if, let's say, money is close to cash. So that we want to understand words, not as they're written, not as the letters they use, as you see them, but the meaning that they have. And again, so one of the big advancements is being able to capture meaning of words into numbers. And it all comes from this this quote here. I forget who it's by, but essentially they say, "You shall know a word by the company it keeps." And what they did with this was they assigned numbers to a word, depending on what other words were around it. And they used a fancy algorithm to do this. But each individual word was assigned different numbers, and typically one word would have like hundreds of numbers. And for those of you who might understand that concept, that's called a vector of numbers. And the idea being that if the words had a very similar meaning, then they would have vectors that were close to each other. And what we're able to do, and I'm just going to flick across to this website down here, is that we're able to plot these words to see if this is true. So if we had a graph and each graph was each word was assigned some numbers, we'd expect words with closer meaning to have a to be closer on the graph. So similar meaning, closer on the graph. So we'll go to this website here now. And what I've done here is I've built this plot. We're using words, and when they're given numbers, we call these embeddings. So that vector of numbers that each word is assigned is called a embedding. And what I've done is I've managed to label the axis fun and boring and old and young. And as I go through this, if you've got any words that you want me to put on the graph, then just put them into the chat or the question and answer, and I'll put those words in. But essentially what this is saying is the relationship between student and teacher is that the student is considered much younger than the teacher and also more fun, and the teacher is like considered old and boring. So question is, can we think of anything that would be more fun than a student? So again, if you've got any ideas of what they might be, you're welcome to put them in the chat. Okay, so I think I know that a comic. Okay, so that is much more fun than a student, and it's also considered to be slightly younger. So the meaning of that word is further away. So what do we think could be something closer in meaning to a teacher? So in university, they're called lecturers. So we add that. So it's slightly more older and boring, but not quite close to a teacher. And so we might have exam. Okay, lecture is very close to an exam because they deal with that kind of, it's all kind of that educational bit. What about something that is potentially more fun than a student? Again, if we look at clown. So a clown is considered more young, but slightly less fun than a student. Can we think of anything more boring than an exam? Well, I don't happen to agree with this one, but it took me a while to find out. And apparently snooker is more boring than an exam. Apologies to any snooker fans out there. But you could also do cricket. So less fun. And we look at things like football. We add that in there. And we look at maybe goal. Okay, so all these kind of sport things are around. Now, it's not, because of the way it's set up, it's not absolutely perfect, but hopefully you can see looking around that by and large, these things, if they're more boring or more fun, they're further away from things that are more fun, and they're young. And I specified these X and Y axis. So if you want to come and have a look and play around with it, a typical thing to do is to use this to try and find bias in word embeddings. And so some people will put in male and female to see if there's gender bias in some of the different professions as explored by these embeddings. So that's the embeddings, and you can see there that essentially what I want you to take away from this is that we have these words, we use a clever algorithm to give them what's known as an embedding, but which is just a series of numbers, and that series of numbers represents its meaning despite the letters that it's made up with, and that meaning means that we can understand when certain words are closer to each other than further apart, because that allows machine learning algorithms to understand, or computers to understand, the meaning of words rather than just the words itself. So I'll go back to the presentation. What we're going to chat about now is building a revision bot. So this is just an idea to show you natural language processing, how it can be done. All of the code that I've used here is completely open source, so you can pretty much do this yourselves, implement it yourselves in any way you'd like to. So what I've done here is I've just decided to do a GCSE revision bot, and I've decided to use YouTube videos to get all of my information from. So I'm going to show you now. Come back here and come to here. So here's my revision bot. So I've got a query here for the GCSE tutor. So I can say, what do I need to know about metals? Now, if you could imagine, you put that into, I don't know, Google or something like that, it would come up with all sorts of stuff about metals that are not appropriate. But the idea of this bot is that it's designed to look at those YouTube videos that are just about GCSE chemistry and then bring you information back which is just useful in that context. And that's what it's about. And what I'm going to do now is go and explain how I built this so that if you want to go and have a look and understand natural language processing, some of the things that it can do, you'll be able to do this. So I won't read that out there, but if you're reading it now, hopefully you can see that the things that it's come up to do with are all kind of GCSE chemistry things to do with metals, not anything else to do with metals. So it's given fairly specific answers. So I'll come back to this, building a revision bot. Okay, so what did I do? Okay, so first things first is I identified the YouTube videos that I wanted to use as my knowledge, and we call this a knowledge bank. So it's building up a knowledge that I want my bot to go and look for, to find the answers. Now, the benefit of this is that, as you've just seen there, when I'm talking about metals, it understands that I'm talking about metals in the context of GCSE chemistry. I'm not talking about heavy metal bands. I'm not talking about generic metal things that you might get off Google, but it's very much focused on this. So I went and found this guy here, free science lessons. Thank you very much. And then I used Python to change these videos with their audio into just text. So basically you get, just this text here on the right hand side, and you get one for each of those videos. And obviously there's loads of videos here. I think I did about 20 or 30 just to get the right idea, but on YouTube there's absolutely thousands, and if you go and get them, you could you could be there for ages. Okay, I do realize there's questions coming on the Q&A, but I'll refer to those at the end. That's not it's not a problem. Okay, they're not being ignored. So here we go. So I've got now the transcripts, and this is where natural language processing comes in. So this part here is actually called automatic speech recognition. But I produced the text, and in the text, it's obviously bigger than that, but it's exactly what's said in each YouTube video. Okay, so the next part is that I then want to embed each of these transcriptions. So I had on the left-hand side, I had my YouTube videos. I then changed that to just the text, and then I put it through a model, which for every YouTube video, every transcription, it gives me a series of numbers which represents the meaning inside that text transcription. So on the right-hand side here, we've got the knowledge bank, and that knowledge bank represents 4 different transcriptions. And so each one of those lines is a different transcription. Obviously, the numbers, are made up. Generally speaking, there would be like, 700, 800 numbers that would represent that, not just the 5 there, but you get this knowledge bank. So we've got that embedding. The next thing that I need to do is I know I'm going to get a query, and I have to give that query numbers as well. So I take my query, I put it through the same model, which gives it an embedding. So again, these numbers here, which encapsulates the meaning of that query. So now I've got my knowledge bank. In this case, it's only showing 4, but it'll have 20, 30, depending how many YouTube videos you do. And I've got my one embedding about my query. So the next thing the revision bot does is computes the distance between every single transcript and the query. And then it highlights the shortest distance for me. And you'll see that when we did that little graph, when it was plotting them, it's exactly the same thing. In that graph, many of you might be aware, it's just 2 numbers. In this case, I'm showing on the screen that it's 5 numbers, but the distances work in the exact same way. And it goes and finds the closest distance. So it's saying this YouTube video is most appropriate for your query. So now I've got this whole transcript, I've got this query, and the next step is to send that text and that query to a generative large language model. And a generative large language model means that it takes input, it takes those language, and it gives out additional text. And a lot of you may be aware of ChatGPT, which is very prominent in the news recently, and that's exactly what I use. Although I really just use it for ease. You can download similar models, and what that does is it takes this text, it takes this query, it looks at previous examples, and then gives me the output which I've just shown you on the other screen there. So that is a brief look at the revision bot and an application of natural language processing, as you can see, particularly using the embeddings to find the things in closest meaning, and then using a large language model, which is very popular at the minute, to generate an output given the information that I've given it. And again, this has all been done with open source material from Python, and you can implement this yourselves with relative ease because everything's relative to some people. Depends how much you've done before. Okay, so last thing to talk about is biases in NLP. And I'll talk about this in reference to the crime stuff that I was doing earlier. So by and large, 3 different biases in AI that you can think about. And I'll start at the top right and then go around clockwise. So the first one is then sample bias. A lot of the models that you can get now that have been built for you, those kind of large language models that we're talking about, which have been trained on vast amounts of data to understand, they are only trained on a certain amount of data. Okay, they can't be trained on everything because a lot of data is closed, it's private, it's not allowable. So that small sample of data is, generally speaking, not representative of the population at large. And in terms of the crime data, what we find is, I'm sure it won't come as a surprise to you, but different people have different relationships with the police. And those people that don't have a good relationship with the police are generally speaking are hesitant to report crime. So what we find is this sample here that we actually have is not truly representative of all crime data, because structurally certain parts of the community don't report crimes as well as other parts, and therefore the sample is skewed to those people who do report the crimes. And so straight off there, you've got a sampling bias. The next thing then is a measurement bias, and that means you can see this here. So depending on the way you look at this, this dial depends on what you see as the temperature. This is known as a parallax error, but you get a similar thing with measurement bias with NLP data, in the fact that, you know, depending on how you've captured that text data, depending on how you've spoken to that person, you know, again, looking at police data, if that person, for instance, can't speak English and they're reporting a crime to a police officer who can only speak English, then that measurement, that accurate recording of that crime is probably not going to be done so well as somebody who does speak English, if a victim did speak English, just because of that language barrier. And that will cascade through to that sort of textual description of that crime. Lastly is you've got algorithmic bias, and it's pretty well known, it's pretty well known that some algorithms work for some types of data well, and different algorithms work for different types of data, even if it's on the same problem. It's just maybe slightly different. That's well understood. What's not well understood is why they work differently and how they work differently. So we know that whenever we run AI, it's as well to check on bias, specifically algorithmic bias, to see if different algorithms and different tuning of those algorithms will help you get less bias in your outputs. And that brings on to a good point. What do we mean by bias in NLP? Well, what we generally mean is that the outcomes is different for different people, but the model stayed the same. So, for instance, more inaccuracies or more errors for one group than for some other groups. And that's particularly what we mean by bias in NLP. So there you go. So bias is important, can lead to problems, particularly with trustworthiness of AI. And so it's important for us as AI practitioners to make sure that as part of our workflow, we have checks in there to make sure that we understand the biases in our data, and we test for algorithmic biases to make sure that the outputs are as de-biased as possible. Okay, and that's it. That's me done. So I will now, I think, go to the question and answers. I have here some questions. Okay, so first one is, can we trust AI with our personal data? I get you should be very careful with your personal data about who you give it to, but I believe that there are some benefits and obviously some risks in trusting. You can't necessarily trust AI because behind every AI currently, there are people who are operating that AI. So it's about who is that organization behind that you're giving your personal data to. And that's a very personal, you know, that's a very personal decision. So in some context, you know, you might give your personal data to medical companies, and that means that they can go and use AI to produce better drugs. And, you know, a lot of people would say, yes, that is a good use of my own personal data, even if it doesn't necessarily give it to me. I benefit. But in other instances, say, for instance, you know, you're on social media and you're giving away your personal detail, this is how they harvest it, that might be used by anyone as a sort of nefarious manner. So you need to be really careful with your personal data. The next question is, so far you make AI sound really useful. Thank you. I think it is. Do you see it as a threat in any way? Yeah, I do see it as a threat. I guess there's two different ways it can be a threat. It can be a threat in this kind of, you know, it can turn into Terminator and kill us all kind of threat, or you can see it in as this kind of lower level threat whereby it accentuates our own biases because we get more efficient at the way we do. And so I think the threat about it accentuating our own biases and then us becoming more efficient in a biased way, I think that's the closest threat that we have to guard against, because if we don't implement AI in a fair way, then people won't trust it. Rightly, they won't trust it, and then we won't be able to get the benefits for the whole of society that it can bring. How did I end up in this career? What did you study at school and university? So I actually was in the army for a long time, for 16 years, and then I came out and switched to AI. But at university, I did maths and statistics, and then I did a master's in data science, and then I did a PhD in the application of natural language processing to crime data. That is one way to get into it, which is a more data science way. The other way traditionally is through computer science. So you've got these two kind of competing ways, either through maths based or computer science. Should we have regulations for revision bots? I'm not sure we should. I'm not sure we should directly. I mean, I'm happy, people should go out and build their own revision bots. And if it helps you revise, gets the information, helps you become a better learner, then I think I'm all for it. Next question is, why did the AI find crimes peaked in winter? There we go. I'll just go back to that plot to show it for you. So it wasn't crimes, it was the percentage of crimes that used force, in burglaries that use force. And the reason for that is because in the summer months, people leave their windows and doors open unlocked because they want to allow the heat to come through. And so burglars don't need to use force. They can just open the door and walk through it. Whereas in winter, where it's cold, people lock their windows and their doors. And so the burglars have to smash them open. And that's why you get this lovely sort of temporal pattern of peaks in the winter for force used during burglaries. Is there a solution to bias in AI, or will it always be present whilst humans are biased? So, and this is from Peter. So Peter, there's two things here. One, the data that we use will almost certainly always be biased, although we can do things to minimize it. So but we can sort of clean that data up. So that's one thing. I won't go into it here, but the mathematics of bias are that there may always be bias in systems that produce errors. So I think nobody would argue with the fact that AI is not going to get everything right all the time. So given that AI is not going to get everything right all the time, mathematically, there can always be bias in the way it gets things wrong. And you might not be able to eradicate that completely, just because of the maths that kind of surround it. But we shouldn't be disheartened by that, because we can, humans are biased now. So really one of the good metrics should be, are we better than humans now, and can we produce more systems whereby we can highlight it using things like data science to make sure that we can reduce it? I think that's true. So I'm not too worried about bias in AI, because I think we can identify it, and I think we should identify it. It's just that I think that people who put it into practice, and people who are customers of AI, so not just the likes of us that would implement it, but they have to be asking the questions about, is this biased? Does it represent everyone fairly? And things like that. So is there a solution to bias in AI? Not completely, but I think there's enough tools in order for us to, one, recognize it, and two, minimize it where we can. And I think that's the end of my questions. Thank you very much for those questions. That's very good.
Anthony, thank you for such a brilliant talk on natural language processing. It's amazing how AI is developing and how we need all of us to be aware of what it's doing, how it's being used, and how we all need to take some level of responsibility for this. Thank you so much for sharing your in-depth knowledge on AI, and thank you to everybody for joining us today.